anyways, the first thing is, if you're gonna prove the Tan Chord theorem, right? You have to, as I said, you have to make a sketch, or you have to draw. It's more like a construction, not a sketch. Let's say construction. Construction, and then you need to know the reason why. So you can say reason for construction. You see, because if you know the reason for construction, you will always be able to remember to make that construction in the first. So this is the first. This is the construction that we make, right? You need to draw a line. You need to draw a diameter. So you can say here, construct diameter. You can label it N, O, and whatever variable you can think of there. So let's do this here. And then this line has to go straight through. There we go. That's the first thing you draw. You have to draw it. You can say construct diameter ONA. ONA. Perfect. Now your second line is very important. Before we draw our second line, let's explain what our construction is supposed to do. So when I say we have to mention what our construction is supposed to do, this is what I mean. Firstly, if you're gonna prove the Tan Chord theorem, you are trying to prove that the angle here is equal to the angle over there. You see? So if that's what you're doing, right, then you need to focus on, your construction needs to focus on these two angles. Meaning the line you can see here, it's coming from where the one angle is. Your second line, your second line has to go to the angle that is equal to the one at the tangent. You see, so there's the angle at the tangent here, then there's the angle at the circumference. So this line here has to go to the one that you're trying to use to prove, or the one you're working with, because the Tan Chord theorem, you're trying to prove that this angle is equal to that one. So your construction has to go to the angle you're trying to work with, and it also has to be coming from the point where the tangent is. Now, the reason for those constructions is you are going to need to make use of existing theorems to help you to prove this Tan Chord theorem. So the reason for making this construction is because the first thing you're going to use is the tangent perpendicular radius theorem to help you. The next theorem you're going to use is angle in semicircle. And then the other, what you may call, the other law you're going to use is angles in the same segment. Now that's the reason for your construction. Your reason for your construction is so that you can use these three laws, because your construction, you firstly construct the diameter, and then we said here you're also going to construct line AK. See? And then you can label here, you can label here O1, O2. Now here, since you labeled this N1, right, you may want to label this one K1, then this one K2. So that's what we can maybe also say. Label K1, let's label K1, K2, N1, and N2. Just label those. Because if you label those, you'll be in good. You'll be good. You'll be good. Yeah, if you label all those, then you'll be in a good spot. Let's see here. Let's see here. Let's see here. So with all these pointers laid out, right? The one thing you want to keep in mind is that you're using these three theorems, right? It doesn't even matter which what you call which it doesn't matter which one you use first. but you just need to state that you can see them. So firstly, the tangent perpendicular radius theorem. You want to state that ON is what you call. You can say OM even. You can say ON or AN, doesn't matter. You want to say that it is perpendicular to PQ. You want to be able to make use of the fact that this angle here is a 90-degree angle. The next thing is you also want to be able to state that this is a 90-degree angle. Thirdly, you want to then be able to state that this angle here, ON2, is equal to K2 because angles in the same segment. So once you'd have stated those three things, automatically N1 and K1 would have no choice but to be equal to each other also. You get it? Because if they are in a spot where everything is adding up to 90, if one angle is a specific value and another angle is a specific value, then it means that whatever is remaining, if you remove something equal, whatever is remaining should be equal to each other, since everything added up should give a 90. So let's just start writing it out so that you see the logic behind our construct. The first thing, as we said, we're gonna state here, AN is perpendicular to PQ, right? The reason here is tangent perpendicular radius, right? Yeah. So with that being said, the next thing here is we're going to state that AKN is also 90 degrees. AKN is equal to 90 degrees. The reason is angle in semicircle. Because if you're constructing, you see, it's a diameter here, so an angle subtended by the diameter is a 90-degree angle. Thirdly, K2 is equal to N2. K2 is equal to N2. The reason is angles in the same segment. Yeah. And then with these three being said, now you can make your statement. You see, you can then say, therefore, K1 plus K2 is equal to 90. N1 plus N2 is equal to 90. Now, these are both equal to 90, right? You can say here, yes. Therefore, K1 plus K2 is equal to N1 plus N2. And then this is where things get interesting, right? But here we said, but N2 is equal to K2. So, but K2 is equal to N2. So we can say here, but K2 is equal to N2. This has been proven. So it means algebraically, you would have here K1 on one side, right, equal to N1 plus N2. If the K2 goes to the other side, it means that these would cancel each other out because they are equal. And then you can say, therefore, K1 is equal to N1. And then you would have proven whatever you're needing to prove, you see, because here they said you should prove the theorem that states that MNQ, MNQ, which is this angle there, is equal to angle K, which is the K1 that we labeled there, which is what you would have done here. See, so you can say, therefore, M and Q is equal to K. Then you will be home free. So give you all your marks. Wow. Yeah.